Hi, today we are going to learn about the bubble sort algorithm, the simplest sorting algorithm. Bubble sorting algorithm is a beginner-friendly sorting algorithm. It is named because smaller elements bubble to the top. It is perfect for learning sorting concepts. So what is a bubble sort? Bubble sort compares adjacent elements and swaps them if they are in the wrong order. It repeats the process for every element until the array is sorted. It is simple but not very efficient for large datasets. So let's look at the algorithm. Start at the first element, then compare it with the next element. Swap if the first is greater than the second. So if the first element is greater than the second element, we perform a swap. Otherwise, we don't need to perform a swap. Then move to the next pair and repeat. Repeat for all elements until no swaps are needed. So here is a code snippet to help you understand with the bubble sorting algorithm. So first we define a bubble sort array. Then we define n, which is the length of the array. So here is a loop. Then inside the loop there is another loop. Now we compare the element with the adjacent element. If the j element is greater than the j plus 1 element, then we perform a swap. So let's see the complexity analysis. So the best case is when the array is already sorted. In that case, the complexity is big O of n. The worst case is when the array is in reverse order. In that case, the complexity is big O of n square. So average case big O of n square, and the space complexity is big O of 1. So let's look at the advantages. Bubble sort algorithm is very simple and also very easy to implement. It is good for small data sets. Now let's look at the disadvantages. It is inefficient for large data sets. High time complexity compared to other sorting algorithm. Now let's look at the example. The first step is to point at the first element, which is 5. Now we compare 5 with the next element, adjacent element, which is 3. When we compare 5 and 3, 5 is greater than 3. That's why we perform a swap. After the swap, 5 and 3 are swapped, and this is the resulting array. Now our pointer was at the first element in the first step. Now the pointer moves to the second element, 5. Now we compare 5 and 8. Now 5 is smaller than 8, so no swap is necessary, and this is the resulting array. Now in the next step, the pointer moves to the next element, third element, 8. Now we compare 8 and 4, and 8 is greater than 4, so we perform a swap. 4 and 8 are swapped, and this is the resulting array. Now the pointer moves to the fourth element. Now we compare 8 and 2. Since 8 is greater than 2, we perform a swap once again, and this is the final array in the first pass. Now 8 is the greatest element and it is in its correct position. That's why in the next pass we don't need to move to the last element, which is 8. In the similar way, the pointer is in the first element. We compare 3 and 5, and since 3 is less than 5, we don't need to perform any swap. In the next step, our pointer moves to 5. We compare 5 and 4. 5 is greater than 4. That's why we perform a swap, and this is the resulting array. Now our pointer moves to the third element. We compare 5 and 2. 5 is greater than 2. That's why we perform a swap, and since it was already in its final position, we don't need to move the pointer again. Now 5 and 8 are in its correct position. Now let's move to the pass 3. The pointer is on the first element. We compare 3 and 4, and no swap is necessary, and this is the resulting array. Now we move the pointer to the second element. We compare 4 and 2. 4 is greater than 2, that's why we perform a swap, and this is the resulting array. Now these three elements are in its correct position. We compare 3 and 2, and since 3 is greater than 2, we perform a swap, and this is the resulting array. Now 3, 4, 5 and 8 are in its correct position. Now in the final pass 5, no comparisons are needed since the array is already sorted. So this is the final sorted array. Now let's look at the key observations. So the total number of passes is n-1 for an array of size n. After each pass, the largest unsorted element bubbles to its correct position. Comparisons decreases with each pass since the largest element are already sorted.